homework. Questions, problems you want to see worked off of. You just have to tell me the page number and the problem. None of them?
I'm looking for all three of those.
5 on week 7. Number 5 on week 7.
Oh yeah, I can do that. What'd you get?
Yeah, I'm trying to
I got
hurry, so I
x
don't-
equals 2 and y equals 9.
Wow,
I
x
got
equals
x.
15 and
I
y
got
equals
x
5.
equals
I got
20 and y equals 15.
I'm not gonna say my life is just over 50, so.
I thought
60?
No.
No.
It's higher.
180.
I got
Higher. 1,000.
All right, I'm not going to draw all these angles in here because we don't really need them all. We got angle 1, angle 5. What can you tell me about those two angles?
Linear pair.
They're a linear pair, so they have to add up to
180.
180. Angle 14 is the other one that they deal with. They say find x and y. Find x and y. What can you tell me about angle 1 and angle 14? If I
Angle 1 and 14
They are
alternate exterior.
alternate exterior. If these lines are parallel, which
Then
they tell us they are and I didn't put it on there, then what do we know about them? They're congruent. So, two equations. We know you just told me angle 1 and angle 5 have to add up to 180, so we could say 6x plus 45 plus, what is it, 3y plus 10? Is that right?
Y minus 10.
Y minus 10, sorry. Y minus 10 should equal 180. What's the problem with that equation?
Do you have two different variables?
It's got two different variables in it, so
So then you could go ahead and do.
let's try the others then.
Yeah. So it'd be 6x plus 45 plus 8x.
Are we gonna add them?
That's equals.
They
yeah.
should be equal to each other, right? So this one should equal 8x plus 5. This is angle 1 and angle 14 because you just told me that they were alternate exterior angles. They have to be congruent.
Minus 5 from each side.
Before that,
Minus 6x.
minus 6x from each side,
2x
which is 45 equals 2x
plus 5.
plus 5
Minus 5.
and minus 5.
From each 2x.
Now, if Katie would have done it minus and 5 from both sides, would that have been wrong? No, it just confuses you more. If you don't get all the x's on one side first, a lot of people get confused.
Yeah, that's where I messed up at. I had 40.
Get this wrong.
I had 40 equals 2x, and I put x equals 20. Wait, that's right. Never mind.
Right, now are we finished?
No.
No, what do you do with
You
that?
gotta put 20 in for x and solve.
All right, if you go back up here and you put 20 in for x, what's 6 times 20? What's 6 times 20?
So we got x. Wait, what? 6 minus.
6 times 20.
120.
All right, so we got 120 right there. We can distribute here. I'm going to try to shorten this up because I didn't leave myself enough room. That's 165 plus 3y minus 30 equals 180. So we plug back in. Now we got this equation. Now we can find y. Let me jump down here. 135 plus 3y equals 180.
Oh my gosh, I gotta find out this number too.
Subtract 135 on both sides.
Nope. I got the first one right.
3y equals, what is that, like 45? Divide by 3, what's y equal?
15.
15. Good.
I think. Oh, I added.
Now on this, if this was a question on OGT, let me look at it again. This is a short answer, so this would be worth 2 points. What they would want you to show, your answers there, that's 1 point. And then this work, how you got it would be another point, maybe. Let me see, find the values of x, show your work. So that's what they'd want. Some of the questions will say explain. Well, then you'd have to say, I know 1 and 14 are alternate exterior angles. Therefore, they have to be congruent to each other, equal to each other. Other questions? Any others on the homework?
Number 5 on the ODT.
Week 8.
Yeah.
Number 5 on week 8. Short answer, find the value of y in the figure, show your work. So again, they want you to show your work. Number 5, week 8. They give us this picture. Couple different ways you could find y here.
Oh, I get it now.
What could you do?
Do act like the, well, don't act, but those two are supplementary.
These two are supplementary, so what's this thing?
70. And then that one's 70.
40 and 70.
That one's 70.
Yeah.
Right.
They're-
Now, they said show your work, so please make sure, especially on like a OGT or
70
park
plus
test or
40.
whatever, do this. 180 minus 110. It doesn't take anything to write that down, right? Make sure you show all your work. Then what?
Add 40 and 70.
Add 40 and 70. Get 110, then you do what?
Subtract it from
180.
Subtract that from 180. Oops, 110. And you get what?
Y equals 70.
So y over here equals
This makes more sense than it did when I was at home trying to do this.
y equals 7.
I did this all here, I feel like
This isn't a whole lot of work to show, but if it's a problem like this on OGT or some, one of those kind of tests, please make sure you show your work. Otherwise, they're not gonna give you full credit. Even if you end up with the right answer, they're not gonna give you that credit. And if they said explain, something you could have done here is instead of doing all that, or the other way we could have done it, you could have said that you knew that the 40 and the y had to add up to be how much? What kind of angles are these two angles to each other in relationship to that one right there? We talked about them last time.
Oh, yeah.
The remote interior angles, right? So these two remote interior angles should add up to be this exterior angle. Well, 40 plus what gives you 110? 70, that's what we said y was. So you could have used that rule instead of the supplementary and the 3 angles of a triangle must add up to be 180. Next question. No others.
I'm looking. Oh, I think I had.
26, is that on 181?
Yeah.
181, number 26. If you remember back to the semester exam, there was a problem almost identical to this on the semester exam. And on that problem, I actually drew the picture for you. And I told you all the problems on the semester exam came from where?
OGT test. I don't know, I think that's
What'd I make you take
oh,
out?
Our previous test.
Your previous test. Well, I sort of lied to you because that problem didn't come from a previous test. But guess where it does come from?
OGT.
A future test.
Ooh.
So what's that telling you about that problem?
Then we already know
It
how to do it.
advanced.
You're going to know how to do it, and it's going to be on what test when you take it here in a week or so?
Future.
The chapter 4 test.
Ooh.
All right, so on this, anytime you're doing a problem like this, first thing you should do, draw the triangle, draw some triangle. Now, did they tell us that it was an equilateral triangle?
No.
No. Is that going to confuse you because I drew an equilateral triangle? No, they didn't tell you what kind of triangle to draw. Just draw whatever triangle and go by what the information tells you. Don't look away from it and get distracted and then go, oh, well, all the sides got to be the same. No, they didn't tell us that. All right? They actually told us that this triangle GHJ, so I'm just going to put the letters in here.
Are we doing page 189?
181, I think.
You did homework on
Right.
181?
Mhm.
Oh, you did. I was looking at the other.
They tell us that this is an isosceles triangle. What do you know about an isosceles triangle?
Two same sides.
Two sides are congruent. Now, right now, we don't know which two sides are congruent, but they're gonna tell us. They tell us that segment HG is congruent to segment JG. You got to go through and do all this every time. Draw the picture, mark the stuff they tell you. Then they tell you that segment GH is x plus 7. So I'm going to label that. They tell us that GJ, 3x minus 5. Then they tell you that HJ is x minus 1. And they want us to find x and find the three sides of the triangle. How can we start to set up an equation to find x?
X plus 7 equals 3 minus 5.
Doesn't like that spot. All right, now watch carefully on this. Could you have, Ruth's looking at this and she says, well, wouldn't it be easier to say x plus 7 equals x minus 1? Is that going to work? Why not? They didn't tell us those two were congruent. So you got to make sure you don't make that mistake. And then here's the other most common mistake that I see students make all the time. Please make sure you're watching completely now, not just half the time, because then as soon as Sarah Ray's sitting there and she's watching for a minute, she's going to look at it, think it's right, and then get distracted and not hear me tell her not to ever, ever do this. What's wrong with that?
I don't know. You could have added your, like,
X plus 7 creates
Oh.
minus 5 working graph, it can't be that.
But what did I try to do here?
Kind of equal 180.
How come I set them equal to 180?
Because the
That's what the angles are, all right? I see a lot of people do this all the time. Maybe I shouldn't even said it in this class because I confused you guys now. But I see students do this continually, where they add the three sides and set them equal to 180. Three sides don't ever have to equal 180. The three angles of a triangle must add up to be not to 180, not the three sides. Here we solve this. Add 5 to both sides. What's x equal? That's part of our answer. What else did they ask us to find?
And this each side of the triangle.
The sides. How am I going to do that?
just plug 6 and plug it.
Plug in. So let's find segment HG first. How long is segment HG? 13.
Oh, I think I did this right.
How long is segment HJ?
5.
And how long is segment GJ?
13.
13. How'd you know it was 13?
Because it's congruent to.
Had to be the same as this one over here. So if you put 13 on that one over there, it had to be 13. I think the one on the semester exam, it actually asked you to go one step farther. And if you see my handwriting in there, the reason it asked you to go a step farther is because I added that in myself. It asked you to find the perimeter of the triangle. Well, what would you have to do there once you found all the sides? Add them all up. Next question.
Can I ask a question? It's about this class, it's not about like a problem.
If it's quick.
Is our grade, I think it's this class, it's in Moodle. Is that what we got on our exam, or is that just like the test grade thing? Or is the same, is it text grade? Can you say your teaching?
Your exam grades on there and
Oh,
your,
I did horrible. I got like 70 something.
if you look at all your grades, your exam grades on there and your final grade should be on there.
You said if we asked you next class, maybe we could see our.
Yeah, we probably won't have time since we might have been able to, but not with the 2-hour delay.
Did you say you got 98?
What else? Questions? Let's go.
32.
Is that on the same page, 181?
Yeah. No, like.
Problem 32 on 181.
Our semester grades are on our report cards for each class.
Yeah, they're in the, they were called like.
Okay, good. I was hoping they would be, because I don't know what I got on my exam.
32 says A is 5, 4. B is 3, negative 1. And C is 7, negative 1. Lots of problems like this on OGT, Park, all that stuff. Because it shows that you know how to do a bunch of different things. They want us to find the length of each side. So we're going to find the length of AB, BC, and AC. We're going to find all those lengths. Then they want us to give the triangle a name according to those lengths. The easiest side to find is which one of these three? BC. What's special about BC?
They're on the same line, they're horizontal.
It's horizontal. Don't say straight, please. It's horizontal. If it's a horizontal segment, to find the length of it, all you gotta do is what? Just count. How far is it from 3 to 7? 4 spaces. So BC is 4. Now the bad thing is for AB and AC, can we do that? No. What do you have to use to find the length of segment AB? The distance formula. Good. The distance formula. Remember the distance formula? Subtract the x's, square that answer, subtract the y's, square that answer. Let's do AB first. What's our x coordinates? So 5 minus 3. What's our y coordinates? 4, negative 1. Good. That's going to end up being plus 1 there. Let's do a lot of this in our head. What is 5 minus 3? 2 squared. Plus, what's 4 plus 1? 5 squared. 4 plus 25. 29. Somebody grab a calculator real quick. What's the square root of 29?
5.4.
5.4. So that's how long segment AB is. This side over here was 4. This side was 5.4. Now we got to do the distance formula and do AC.
Wouldn't they do the same thing?
I don't know, is it?
Because it's an isosceles triangle?
It doesn't tell us though.
Oh, yeah. Well, it looks.
If it did tell us that, then yeah, it'd have to be the. If it told us it was isosceles, this side would have to be the same as one of those two. But do we know for sure which one yet?
5 and 7.
5 and 7, so 5 minus 7.
And 4 plus 1.
4 plus 1. What is 5 minus 7? 2 squared. Negative 2 squared. 4. 4 plus 1.
25. 29.
So is it the same?
Yeah.
Yeah. How long is segment AC then? 5.4.
So then it must be 9.
That's part of our answer up there. They wanted us to name this triangle, so you guys are telling me what kind is it? Isosceles triangle. It's an isosceles triangle. Gotta be able to set up equations, do distance formula, all that stuff. Other questions, real quick?
Is that point from Mr.
Prime Minister Hay. I think he's over break. I think his hearing aid needs a new battery or something. If you hear him, he's been talking louder, so he probably can't hear.
Imagine if someone turned his hearing aid off. He wouldn't hear any of us all class.
He doesn't care to hear all of it. Whereas I get mad when you guys sit in here and talk, you ain't give a crap one way or the other, because you know what's going to happen. You do it in his class, you'll be lost, and then you'll come up to him and you'll say, "Can I get some help with this?" And he'll say, "No, you remember? You remember when you were sitting back there talking the whole class and you weren't listening? Nah, I don't feel like wasting my time with you now. Go
We
away."
can just come to you.
Yeah.
That's how
I'll probably be in this.
I'll probably
there's a
say the
chance he'll
same
be in this
thing.
intervention class next year.
But I feel like he'd do that. Like he'd turn his hearing aid off, and I'd have a full conversation
conversation with him, and I would have no idea. And I feel like the dumbest person on earth.
No, I'm just kidding.
What time is this class end?
I don't know.
122.
You got about 4 minutes to work on that worksheet, then I'm gonna collect it.
So this is the quiz, right?
Yep, some of the problems on there are the quiz.
Okay. There's so many, the postulates and theorems for this chapter, they're all like theorems and it's really long.
Are they long?
Were we
I had this
supposed to
split up in
cover
half, I had
this?
half done, I had another half.
That's
This
probably,
is
that's,
half.
see, that's probably why I gave you, why I said that on that other part, just so people get started on them, because I
Yeah,
knew
I
they
have
were
like,
long.
this is not want us to copy down the corollaries, like.
Yeah, the corollaries, copy them down.
Okay, I put them down.
Thank you, Katie.
I put them down just in
Katie,
case.
reach back here and
I
give her
put
one of
them as-
these.
I put
Mr.
them,
Eversole said that like 10 times last
That
time.
corollaries are postulates.
Corollaries or postulates?
Well, I know, but
well, I
I
put them down as corollaries because I know shit on the test.
It
it's
doesn't
gonna say,
matter.
like, corollaries.
Yeah, I put them down as corollaries.
I took it on
Because
the
you're looking for like 10 minutes.
We'll see.
Okay.
All right, what we're going to cover today, proving triangles are congruent and using congruent triangles to solve problems. We got to hurry because we got a lot to cover.
What's it always the days with so much time and so much time?
When you prove two triangles are congruent, there's actually a section that we're skipping that talks about the different parts of triangles and saying two triangles are congruent. We're going to skip that because it's sort of like extra work, but it gives you the idea. How many different parts does a triangle have? Think for a minute. How many different parts? 6. Has what? 3 sides and 3 angles. Alright, so it's got 6 different parts. The section that we're skipping wanted you to show all 6 parts of one triangle are the same as all 6 parts of another triangle, and that means that they're congruent. But what we're going to cover today is some math people a long time ago went through and figured out, hey, there's shortcuts to this. You don't have to prove all 6 parts in one congruent to all 6 parts in the other. What you can do is use these shortcuts to get to that. Did you get it?
Yeah.
So we're going to learn those and be able to use those congruent triangles to solve problems. So if you're given two triangles, what the section that we're skipping would have said is this angle is congruent to that angle, this angle is congruent to that angle, this angle is congruent to that angle, this side's congruent to that side, this side of this triangle is congruent to that side and that triangle, this side's congruent to this side and that triangle, and then we could say the two triangles are congruent. Well, instead of going through and proving all of that, we're going to learn shortcuts to those. And anytime you see this word, what should you probably know is we're going to have a bunch of it in this section.
Writing.
What kind of writing? 2-column proofs. Now, these 2-column proofs that we're going to do are going to be a lot, I don't want to say easier, but probably a little easier because you're going to have a blueprint for your 2-column proof. All right, go ahead. Can you see that?
Not really.
Go ahead and just write down,
That's better.
write this down. This is definition of congruent triangles. Definition of congruent triangles. Two triangles are congruent if and only if their corresponding parts are congruent. Now, what I mean by their corresponding parts. Earlier this year, we learned about transformations. What were the transformations that we learned about earlier this year? Slide. What? Reflection. What was the easy word for that? So I don't have to write reflection. No.
Flip.
Flip.
Dilation.
Dilation.
And
Translation, same as slide.
Transformation.
Let's write them down. We got
Rotation.
a rotation. What was the easy word for that? So I don't have to write that down. What was it?
Yeah, that's
Turn. Right? So we had turn, slide, and a flip, right? Those were the easy words. And we also had dilation. Now I'm not putting dilation up here because dilation doesn't work to make congruent triangles, because what's a dilation do to a triangle or any shape? Dilation makes it what?
Bigger.
Bigger or smaller. So these are the ones that we're going to be using. What would you have to do to triangle ABC to get it to match up to triangle FDE? What would you have to do to which one of these three? If you wanted to match this up, what would you do to it? Just slide it over. Right? A translation, just slide it over. That's what they're saying. Remember, corresponding, angle A in this triangle would correspond to what angle in the second triangle? Which angle would angle A correspond to in that second one? Angle F. Remember, corresponding means when we were doing the parallel lines and you shove the lines together and the angles laid over top of each other, same thing here. What's each one going to lay over top of? So angle A would lay over top of angle F. Angle B would lay over top of
Wait,
D.
D.
And C would lay over top of E.
Sorry with that.
What would segment AB correspond to?
FD.
FD. All right? That's what we're doing when we're dealing with these congruent triangles. We're matching up the parts. Now, sometimes this one's just a slide, so you're just going to slide it over to get them to match up. Sometimes you may have to flip it over. Sometimes you may have to turn it, rotate it, whatever. But you're going to have to be able to do that in your head. All right, the way a congruency statement is written is important. A congruency statement is this. If I draw a triangle, you might want to draw these triangles down there so you know how to do them. Notice, do I draw basically the same triangle every single time? Yeah, does that mean that every triangle is going to look that way? No. Give me 3 letters for this first triangle.
ABC.
I heard ABD first. Give me 3 letters for the second triangle.
K and B. I was gonna say, I'm like, hey.
Can't use B. We already used it.
C.
Now, the congruency statement, if I mark this triangle, let's say I mark it this way. You got to make sure that the parts that are congruent to each other match up when you name the triangles. The way you name the first triangle makes no difference. So somebody name that first triangle for me. ABD. Now what matters is when you write the congruency statement, which is what I'm writing right here, when you name the second triangle, you have to make sure that they match up correctly.
So you have to name it in the exact same order as you did.
So A matches up to what in this one?
K. So
K.
ACN.
B matches up to C, and D matches up to N. Now, did everybody have to name the first triangle ABD? No, you could have named, give me another way to name this first triangle.
ADB.
ADB. If you do that, oops, yeah, my pen's not working. How would the second triangle be named? KMC, everybody agree with that? My pen would work? All right, now could you name them a whole bunch of different ways? Yeah, but you got to make sure that they match up. All right, just write these 3 things down. You might skip one line in between them, but we're going to write one basic thing.
Do I have
Dang on
a
it.
paper from last class
Do
that
what?
we started with notes with the, I think they're just postulates, 4.1 and 4.2.
As long as they're separate notes, I can tell you. All theorem 4.4 says, again, remember this is your notes. All theorem 4.4 says is all these properties, which we've already learned this year, work for algebra, work for segments, work for angles. Well, this theorem just says that all of these work also for what? What are we covering today? What are we covering today? Triangles. So these all work for triangles also.
That's all we're gonna write.
Yeah. Well, we're going to write down what each one is just to make sure everybody remembers. Remember, reflexive property, this one's very important in this chapter. Reflexive property says, for triangle, says any triangle is congruent to itself. So the reflexive property would say triangle ABC has to be congruent to what? Triangle ABC, if I could ever write. Stupid pen. Now, the reflexive property, I'm just going to write out what it is. Anything, so you remember it, anything equals itself. What is going on? We use this one a whole lot more than the other two, so I'm not going to put a whole lot of effort into the other two. Does anybody remember what's the symmetric property say? Symmetric property says A equals B, then what do you know?
B equals A.
Then B equals A, just turns it around. Transitive property says
If A equals B and A, or B
And B
equals C,
equals
then
A
A
equals
equals
A.
then A has to equal C. So this one would say, for triangles, it would say if triangle ABC equals triangle QRS, then triangle QRS equals triangle ABC. Just turn it around. And this one, I'm not going to go through all that because that's too much for me to say. The first triangle equals the second triangle will equal some third triangle, then the first and third triangles have to be equal. We don't use these two a whole lot as far as the triangles go, but reflexive property we will use a bunch this chapter. All right, this is the most important thing today. These are the 4 shortcuts. These are the 4 shortcuts to proving these triangles. Instead of have to prove all 6 parts of one triangle are congruent to all 6 parts of another triangle, these are the shortcuts that we're going to use. So we can say 2 triangles are congruent because of SSS. Anybody have a guess as to what SSS stands for? Side, side, side. So what that's saying, I'm not going to draw a picture for every one of these. You can draw the pictures if it helps you. We have 2 triangles. You know that this side's congruent to that side. This side's congruent to that side. This side's congruent to that side. Then guess what we can say about those 2 triangles? They're congruent. Anybody have a guess as to what SAS stands for?
Side angle side.
Side angle side. Now you got to be real careful with side angle side. If I was to draw the 2 triangles here again, this side's congruent to this side's congruent to this side. The angle has to be what's called the included angle. What do you think that means, the included angle?
So like the angle between side 1 and 2.
The angle between the 2 sides. So it'd have to be this angle is congruent to that angle. It has to be that angle. It doesn't work any other way. Same thing on this one right here. Guess where the S has to be? The side. Between the 2 angles. So this one's angle, side angle. Now before we get to the last one. Again, this side has to be the included side. Has to be between the 2 angles. These are like your blueprints. So if they say write a 2-column proof to show that these 2 triangles are congruent, you're going to go through and say, all right, I got a pair of sides. That's going to be one of your statements. Got another pair of sides, that's gonna be another statement. Got another pair of sides, that's another statement. So you got like a blueprint to go by. Which ones don't you see on here? Give me something you don't see on here. We got side, 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 angle, side, angle, side, angle. Say it again. Angle, angle, angle. All right, angle, angle, angle doesn't work to prove two triangles is congruent. So make sure, if it helps you, write down angle, 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 put an X through it or something. It does not work. It proves that those triangles are similar to each other, and we're going to talk about that on down the road. What's another one we don't have?
Side angle angle.
Side angle, angle. Well, we sort of do have that one. It's just backwards.
Angle side side.
Angle, side, side. Get rid of that.
It's like on back.
Angle, side, side. Does that one work? No. And Katie's back here snickering. Katie's back here
I was
snickering.
fixing my mouth thing.
And Sharice is behind her snickering. So if you try to use that one,
Katie.
I wasn't looking up the
if
word.
you try to use that one, what are you going to know?
It's so not
It
right.
doesn't work. It's wrong. All right? Last one. Angle, angle, side. Now, angle, angle, side works because of angle, side, angle. And because of a theorem that we had last time. If you had these two triangles, you know this angle is congruent to this angle, and you know this angle is congruent to this angle, and you have this side is congruent to this side. Well, what do you know about these other two angles? They have to be congruent because we had a theorem that said if two angles in one triangle congruent to two angles in another triangle, the third pair have to be congruent. So this is like the baby of that one. It's like the offspring of that other theorem. It comes from that. These are 4 ways to prove two triangles are congruent to each other. So instead of proving all 6 parts in one triangle congruent to all 6 parts in the other triangle, we only actually need 3 parts in each triangle. These two triangles, why would they be congruent?
Oh, side side.
So what would you write?
Side
Side,
side.
side, side. Side, side, side. How about this?
Side side.
Side angle side.
Side, angle, side.
Oh yeah.
All right? Now watch carefully on this one. Are those two congruent?
No. Yeah.
Oh.
What would it be?
Angle.
Side, side,
Or
angle.
side side angle.
Side, side, angle. Is that one of ours? No, so not congruent. All right, that's your assignment. It's only like 10 problems or something on the 2-column proofs. Whenever you're doing a 2-column proof for this chapter, please make sure you write the problem down. So you're going to write given, whatever it tells you on the given, prove, whatever it tells you on that, and draw the picture. Whatever the picture is, the 2 triangles. That way you can label everything. Pen would ever work. That way you can come over here and say, okay, I know these 2 sides are congruent, I know these angles are congruent, and you can label everything throughout the picture. Try them. I know you won't enjoy them a whole lot, and they won't be a whole lot of fun, but try them, and we'll probably, next week, we'll go over quite a bit of it.